So we're going to be finding the length of a line using the distance formula. So we're going to be looking at coordinates on a coordinate plane, and we're going to be figuring out how can we figure out the distance between those points. And the distance between 2 points is another way of saying the length of the line. So when I'm looking at these examples here, if I said the distance between A and B, I'm actually measuring the length of the line that connects A and B. Right? So we can think about distance between points as also calculating the length of the line. So in each of these examples, I'm giving you 3 different versions of this line segment AB, and I'm asking how long they are. So here's the kind of nice thing on the coordinate plane. If you have a vertical line like this one, and you can just count the boxes. We can say in this case the distance between A and B is 1 block, 2 blocks, 3 blocks, 4, 5, 6. This looks like 7 blocks. So I would say in this case 7 is the length between the length of AB. If I were to look at a horizontal line, I can do the same thing. I can say 1, 2, 3. Right? This is 3 units long. Here's the problem, though. When I get to a problem that is not horizontal or vertical, so it's diagonal in some way, I can't count boxes, because if I were to measure the distance from here to the end of that one, that's not a full distance. I'm not counting 1 block. I'm kind of going through the middle of the block. That's a problem. So I can't measure the distance between points that are not horizontal or vertical, so we need another way. Right? And so let's think about that other way. So if I were to give you this problem, this is our bad situation. I don't know how to find the distance between these 2 points, and so I'm asking you to find the length of AB when A is at 4, 1, and B is at -2, 2. So I've already taken the time to graph those just to save us some time. And so what we're going to do here is we're going to take advantage of our horizontal and vertical lines. So just graphically, if we look at this, we can say if I were to measure just the vertical distance between A and B, that would be 1, 2, 3 units. And if I were to measure the horizontal distance, okay, like this, that would be 1, 2, 3, 4, 5, 6 units. Right? And then I can say, well, look what I just created. I created a right triangle, okay, and the right triangle has a hypotenuse of AB, and I know the sides. So what I can do is I can say, if I use the Pythagorean theorem, which you should have seen before, okay, I now know the 2 legs of that triangle. Right? So I can say that the AB, right, my missing length, which I'll call this one C, okay, is 6 units and 3 units for my legs, which are the A and the B. So I'm going to say 6 squared plus 3 squared is equal to C squared. Well, this is 36 plus 9 is C squared. And 36 and 9 is 45. Okay? And so I can finish this one up by taking the square root on both sides. Okay? And so if you leave this in radical form, if you remember simplifying with radicals, right, you should say that this is the square root of 9 times the square root of 5, which is really 3 square root of 5. Okay? If you were to take the actual square root on a calculator, you would get a number about 6.7 or 6.8, but we actually want to keep the exact form. We don't want to round this distance, and so I'm going to leave it like that and say 3 square root of 5 is the length of AB. Right? So you can see, using the horizontal and vertical lines, this is really just Pythagorean theorem problems. Okay? However, I don't want to have to graph every single problem when they ask me about the length of a line. That's very tedious. It takes a lot of time and a lot of effort. So we have a formula that accomplishes exactly this. Right? So here is the formula. Right? And so if you take a look, it's fairly complicated looking. Okay? But what this is really doing is it's figuring out the Pythagorean theorem parts for us. Right? And that's what these kind of, well, let me grab my highlighter instead. Okay. These little pieces here, when I say x2 minus x1, if you notice on my graph here, that's really just calculating the horizontal line, and y2 minus y1 is calculating the vertical line for us, right? And then the rest of this is really just the Pythagorean theorem, right? It's saying, here's my a, let me grab my pen again, okay? Here's my a squared plus, there's my b squared, and usually we would have like a squared over here, but they just decided, well, we'll do the work for you. We're going to do the square rooting that you would have to do at the end, and they just made that a part of the problem. Okay, so this distance formula is really just the Pythagorean theorem, but in terms of coordinates, and all solved out for you. So you're going to need to know this, okay, and we'll be doing a lot of work with it to help you to remember it. right? But we're going to just go through and do one application of this where you can just look at it and say, if I give you this SR, and now I'm not giving you a graph anymore, how would you quickly find the length of SR? So that's why we have this formula. I don't want to have to graph something that goes all the way out to a y value of 14. So I'm just going to say instead the distance between these points S and R, which is the length of SR, is just going to be represented by, if I call this x1 and y1, and this is x2 and y2, I can just say subtract the x value. So I'm going to say negative 2 minus 3 squared plus, and I just have to keep my order consistent. I started with this one, so I'm going to start with the 14 in the same point. 14 minus negative 1 squared. Be careful. Negative minus negative there. So I'm going to simplify each of these. Negative 2 minus 3 is negative 5 squared. Okay. 14 minus negative 1 is 15 squared. And there's a big square root over all of this that we'll do at the end. Okay. So let's keep going. Negative 5 squared is 25. 15 squared is 225. Still big square root over all these. So the square root of, when I add these together, I'm really saying it's the square root of 250. Okay? So it says, what is the length of SR to the nearest tenth? So I can go grab my calculator, okay, and type in 250 and ask it to do the square root of that number. And I can get the decimal version to the nearest tenth and say it's about 15.8. Okay? It also asks for us for simplest radical form. And so when I'm doing that one, I'm going to say, well, this is really made up of a 25, okay, and a 10. That's how I'd get 250. And I'm doing that because I know what the square root of 25 is. It's just 5. So I can say 5 square root of 10 is the radical form. 15.8 is the decimal form rounded to the nearest tenth. Right? And so that's all we're really trying to get at here is we're just asking you to use the distance formula, okay, which takes some time. It takes some getting used to. And then after you've used the distance formula, you'll be told whether to put your answer in terms of a decimal or in terms of a radical. I would say if you're not told one way or the other to always leave it in radical form. We like exact answers. We needed to round this one. The actual answer was like 15.8 something, like it kept going. So we had to round it, right? So we would prefer to keep our answer in radical form. So if you're not told specifically, leave your answer in simplest radical form.